we are live. Yes. Hello,
Okay, hi.
everyone, and welcome to another session at Testmur Conference 2024. I hope you are having an amazing time and soaking up all the knowledge this conference has to offer. I am Swapna Biswas, Product Marketing Manager at Lambda Test, and I would be your host for this session. Today, we are going to deep dive into using state machines with Playwright. And for that, we have Gopi Shankar Haridas with us. He has over 11 years of work experience in the field, and he is currently an SDET at Direct Link Group, where he is passionate about test automation solutions, analyzing testing gaps, and proposing effective solutions to improve quality. He also has a strong background in testing and automation. In this session, we will explore how to use state machines, which can help automate interesting scenarios more effectively. Before we start, we have a couple of points to remember. Feel free to drop your questions in the Q&A tab, and if time permits, we'll address them at the end of the session. Remember, all the sessions are being recorded and will be available on Lambda Test YouTube channel at the end of the conference. So if you miss anything, you can always revisit them and share it with your peers. And do share your favorite sessions, snippets, learning from the session on social media channel with the hashtag TestMeConf so that we can select the winners for the giveaway prizes. With that said, let's welcome Gopi. The stage is all yours.
Hey, hi everyone. Uh, Let me just quickly share my screen first and then we can talk about the session. Okay, I hope my screen is visible to everyone. Cool. Yeah, getting thumbs up. All right. Yeah, thank you so much for the introduction and thank you so much for everyone to join the session. This is perhaps a wonderful conference that I've been attending for the past 2 days, even though I was not able to attend the last day, but the first day was pretty good. I was able to attend most of them. Okay, so today we're going to talk about state machines with Playwright. Again, I think a quick introduction has already been given by Swapnil, but yeah, uh, there's not a lot much to say. I'm working as a SDET in Direct Line Group, and currently did a role of developer, QA, and SDET in different organizations and in UK and in India. So currently, I've been working with as an SDET in Direct Line Group. It's more of different changes, mostly focusing on shift left testing. So it's a lot of challenges. And cool. So I think that's good introduction. Let's go with the agenda. Okay, so we'll talk about model-based tests first. Um, then we will be talking about state machines and the components, and we will then have a real-world example. We'll try to have an analogy and try to relate that analogy with state machines. And then followed by that, we will have an introduction to a library called XState, which basically helps us to build state machines and state charts. And after that, we'll go to a quick demo. I would try to get my hands dirty on building state machines and, of course, creating model-based tests so that we all can see how it goes. And after that, I'm open for questions. So without further delay, let's start. What is model-based testing? Okay, model-based testing, it's a innovative topic. It's an innovative technique where we create a model of the system, and we basically helps us to it basically generate tests or create tests out of it, or provide where we can build test and generate tests out of it. So what it basically does, it's like you have, let's say that we have an application, and we keep those application as the center part, as a system under test, and followed by that we would just build our interaction just like a UML diagram. So if there are different technical and business flows that we would have seen in UML diagrams, right? You can consider state machines or finite state machines. Finite state machines pretty much the same. So model-based test uses finite state machine, and the tests generated or produced are basically self-documenting and very easy to maintain. I would basically show how it is easy to maintain through the demo. So that's pretty much needed to understand the magic behind state machines. So As I mentioned, the test paths are automatically generated, and just like how we can closely relate with the UML diagram, where you have the a flow from one state to another, and then you can generate. We can think of different tests there, right? Different test cases there. Similarly, you can consider state machines as like where you can have one state and another state, and then we can try to find out, try to see how the transition works. What are the different transitions? What are the different events it can help to take us to next states? Uh, don't worry, I will be explaining all these things in the next slides. So, in a nutshell, model-based testing basically uses is a model where the model is basically the system under test, and we can generate test paths and test cases out of it. Cool. And I would also like to explain about the advantages of having model-based tests. So one of the clear-cut advantages is about the visual representation of the system under behavior, system's behavior under, which is under test. So which is very easy for us to design a test. Again, you can take UML diagram here, where you actually point an arrow from one state to another, and you can easily understand how the flow works. Right, just like that, we can consider state machines. So it's an advantage is a visual representation. So it's very easy for us to create tests, produce tests, at the same time generate tests. A couple of the disadvantages which I can talk about is about the steep learning curve. State machines are quite something. It would take some time for us to understand how state machine behaves, how states and events and transitions behaves. So it's quite a steep learning curve. So I would personally recommend audiences to give a thumbs up just in case if you understand state machines during my next slide, not here, so that it also helps me to understand that we are on the same page. Okay, so that's basically about model-based test. And well, what is state machine? I've been talking about states, events, state machines all this time. So let's talk about state machines. State machines are also known as finite state machines, are computational models, which basically helps us to understand, design, or describe the system's behavior. So when I say design and describe the system's behavior, the system or the application that we are currently testing and how it behaves to different user inputs is something that we can build using state machines. So state machine basically builds the whole system with all the states and transitions. So when I say state and transitions, I could say I would definitely come to that in the next slide, where I can create with an analogy, relate with an analogy. But basically, it represents the system as a collection of states and transitions from one state to another based on the events. So it also helps us to capture all the states, events, and transitions between them, so that the whole system that we have, or the whole project, or the system, or the product or the project that we want to test, is bounded together in one state machine. So a couple of some of the advantages that I could call out for related to state machines is it's very easy to understand because it's a visual representation. State machines are visually represented, and it's very easy to understand. It's very easy to communicate with stakeholders. Like you can basically show the state diagram, simulate the state diagram, and show to the users like how the system or how the product behaves to the end user. So just like again, same with the UML diagram. It's very easy to test as well because it's very deterministic, which means they are very simple to test. The tests are being generated path. You can test almost all the possible paths and transitions between them. So it's very easy to test. I can basically talk about or show how easy it is, how simple it is to test in the demo. And yes, implementation. Yes, it is. We can implement with. You can basically implement state machines all on your own. You don't really need a library. In fact, the library that I'm going to introduce in the next few slides, the author of the library has personally even created an article where you can create state machines on your own without the need of state machine library by itself. I can quickly share it with you as well, so that it's very interesting. And let me quickly share it here. In the chat box. All right. Yes. Yeah. So you can create a state machines with just conditional statements, switch cases, if else conditions, and you can build your own state transition or state machines all by yourself without the need of a library. Yeah, but we are using a library just to make things to get rid of all these hassles. So once you try to build a state machine all on your own, you would understand how complex it is to understand, or how complex it is to read the code. So that's where the libraries like XState or many other libraries like Squirrel, etc., comes into the picture. They also helps to prevent bugs. So you can consider states like, let's say that user is signed in, user is trying to sign in, user is signed in. These are two different states, and any issues that we fall around the sign in or around after sign in, we can basically narrow down to the particular state, which helps us to prevent bugs and narrow down, have the separation of concerns over there. Cool. So I think I have. Let me just quickly look at my air meet so that people. Is that a thumbs up? Just okay, cool. Thank you. Let me just quickly switch back. Okay. Well, I've been talking about state machines for a while and talking about states and components. So state machines, what do they actually contain? Like, what are the different parts of state machines? That's what we're going to talk about in this slide. Components of a state machine. We're going to talk about 4 important components of a state machine, and there are many other components that builds a state machine that we can help us to route the transition between one state to another through different ways, through different attributes. Like, there are a lot more things. It would take a lot of time personally to explain all these things. So I'm just going to share 4 important components of state machine, which basically helps us to understand state machines, at least on the very basic side. So the first one is states, obvious one, state. And second one is events, transitions, and actions. So these are the 4 components of a state machine, which basically helps us to, that's important for a state machine to be built. State machine states basically describes the machine state or that particular machine state. It can be either idle or ready, or it can be either idle or busy. The machine state at that particular time is what you call a state. There are different states. Our application, just like our application behaves, right? There are different state, and they all are marked as separate state. They all are created in a state machine. They all are separately or categorized in the state machine. Similarly, I want you people to understand closely what's this. Events and transitions. Events and transition comes together. So a machine moves from one state to another through transitions. Okay, and the transitions are caused because of the events. So when an event happens, the machine transitions from one state to another. So if you look at these words, right, transitions is more like the action, or sorry, event is more like an action which helps us to move to the future state. Okay, I have 2 states, A and B, and I want to move from one state to another state, or I have to do some events to get to the state B, right? So even a simpler analogy is that I can closely find is about a dog, right? A dog being being awake and sleeping. Okay, the dog is currently awake, and there are 2 states. The dog can be awake, the dog can sleep. Okay, so how can a dog sleep? If you consider from the state machine point of view, if there is an event where the dog tries to fall asleep, then the dog will move to the next state, which is basically sleep, right? Similarly, if a dog which is currently sleeping, and if there's an event which says wake up, then the dog will be as per the event, it will fall to the next to the state awake, right? So I think this example is something that you can very basic example which I can try to give here, because transitions and events can be sometimes confused when we try to work on state machines. So hope things are clear here. Just in case, I would like to get another thumbs up so that people are able to follow here. All right, cool. Yes, going back. And yes, then what is actions? We left out the 4th part, right? Actions are executed when a transition is triggered. So in our analogy, actions are the action that helps us to fall to the state is basically yawning, right? A dog yawns, okay? The event happens, dog fall asleep is the event, and it yawns and then falls asleep, right? So that's basically the action. So these are the four components that we can that a very basic state machine would have. There are many other states. For example, there is initial states and final states. Initial state is where the state machine begins its operation, and final state is where the state machine ends or ends execution. State machine ends execution. Yeah, I think I have made things clear here. I would show all these things in the demo with a very basic state machine diagram. And of course, there are many other components as well, just in case, as I mentioned, there are many other components that we have in state machine, like parent state, atomic states, parallel states, and sequential or self-transition states, right? So these are different states, these are different components that can help us to build complex state charts. For example, parent state is more like you have a parent state and then you have a child state. So only when the parent state is executed, your child will be executed. Similarly, there is parallel state where you have multiple child states and then all of them can be executed simultaneously, right? So self-transition where you just point to the same diagram, same state all the time. So that is possible. There are different components as I mentioned. So yes, there's still we can use all of them to build complex state charts. Well, when I say state charts is pretty much an extended version of the infinite state machine, the state machine that we have. So we can build complex state machines, and those complex state machines are basically called as state charts. So when you build a state machine, you have states, actions, states, events, transitions, and everything here. And when you have more logic towards it, for example, when you want hierarchy like the parent state, or when you want a concurrency like a parallel state, okay. So when you want to bring in more logic inside, that's what we call as state charts. So it's pretty much the same. So in a nutshell, I can say that state machine is a simpler model, and that's excellent for systems with very basic systems, or relatively that has a relatively straightforward behavior. And whereas state chart is an extended version of the state machine with more complex behavior or complex logic. Says it has a visual extension of the state machines. I mean, both state machines and state charts can be visually you can visually see it visually. Cool. So let's take a real world example now. So I'm trying to be as basic as possible. So we have an automated teller machine, ATM, right? So if you look at this state machine, if you look at this if you look at this real world analogy, the person who is currently inserted the card in the ATM is in one state where the person has inserted the card. So when the person has inserted the card is being read, and the person can decide on next action whether to enter the pin and then move forward with the selection and then withdraw money, or he can just cancel it because he feels that he don't have any money in his account left. So that's basically what it means, right? So the person has entered the card, and he tries to enter the pin, and then he remembers his pin, and then he selects a transaction. And once he selects the transaction, he sees that, okay, I can select withdraw transaction and I want to withdraw some amount. So let's withdraw some amount, and then the cash is being dispensed. Alternatively, if a person has inserted a card and he feels like, okay, I don't really have any money in my account. Why should I even be in this ATM? Let's cancel it and move on. So he clicks on cancel and the transaction is aborted. Similarly, it can be different. Like you can cancel at any part of the stage, right? So it's more like a new different path altogether, like for the alternative action. So when you enter the pin and then you select the transaction to use, you could see the balance in the screen, and then you see like, okay, I don't really have a lot of money to withdraw. So what I would do is just cancel the transaction, and that would basically return to transaction aborted. That will be an aborted transaction. So now I want to get to know how people understand this analogy. I try to be as simple as possible. So does it make sense? Okay, cool. All right. So let's switch back. Yeah, thank you for that. Okay, so now it's an introduction about XState. as I told you, right, XState is the library which basically helps you to build a state machine. It's or orchestrate a state machine and orchestrate a state machine or state charts. It's more specific towards JavaScript and TypeScript web applications. It can help us to build complex logic in a predictable and visual ways. So as mentioned in the earlier slide and in the article that I've shared, you don't really need a state machine you don't really need a state machine library to build one, but having a state machine is really worth it. So XState provides a powerful and flexible way of managing applications and workflow status by allowing developers to build and visualize and see it, build the state machine and visualize, see it, how the application behaves for different user inputs. Okay, so yeah. So that's basically about XState, and yeah, I just targeted 20 minutes and it's exactly 20 minutes. Let's jump for a quick demo. Let me quickly share my screen here. I would stop sharing and reshare things again. Okay. All right, now we don't really need PowerPoint. Yeah, sorry for the delay. I'm just trying to arrange my windows properly so that things are fine. Okay, so as I mentioned, XState is the library, and we can basically create, just like any other library, you can include that library as part of your package.json and basically install it as your dev dependencies, and then you can basically use all the features of XState. So I have my XState library present installed here as part of my dependencies, and I just XState provides create machine, a method which helps us to create a state machine, and we can basically create a state machine using this create machine method. So what it takes is basically an ID, which is basically the name of the state machine, and then you have to specify the initial. So if you remember, I've talked about initial and final, right? So initial is a stage where the state machine starts your execution. So I specified the initial state as idle, which is basically here, right? So if I try to relate the analogy of automated teller machine here, we can build a new state machine here. So this is the idle state, and what happens, the insert card is basically the event, and the card inserted is the next state. So it goes like you insert the card and you take it to the next state. Okay, so now let's get our hands dirty. Let's build a new state. Okay, so it's basically about, we have card inserted, so we need to create card inserted. We need to define the state card inserted, and yeah, I'm just looking at the chat box as well. Okay, so you have to define the card state so that it helps you to understand. So just in case, so there is in Visual Code there's an extension which you can use, like Visual Editor. So when you click on open Visual Editor, it basically builds the state machine here. Okay, so the insert card is a transaction, and this is the next state, insert card. So now let's build it, right? So card inserted is the next state, and then we have to specify the syntaxes. There can be different ways to specify declare state. Either it can be like on the next event is basically you enter the pin, and basically you have to specify the next state, which can be pin entered. Okay, so you specify the next state, but the next state is not defined. So that's why it says pin enter does not exist in the automated trailer machine. So we have to define the next state, right? So alternately, when a card is inserted, you can either enter the pin or you can cancel it. So we can also specify the cancel event. It's way too slow. Yes. Which takes us to transaction aborted, right? Or abort transaction. Yeah. So now we have two new states, pin entered and transaction aborted. So what pin entered basically means that if you have pin entered, okay, I'm just looking at the screen as well. Pin entered, which is a new state, which takes us to a different page now. So you have entered the pin, your pin is successful. Now you have to select the transaction. So what I'm going to do is I'm just going to create another event and takes to another state. So pin entered will take you to select the transaction. I'm just looking at the time. It's around, if I'm not wrong, it's oops, sorry. Yeah, it's 25 minutes now. Okay. I'll just try to wrap it as much as possible so that we can move to the model-based part, which is something pretty interesting to look at. So transaction selected. Okay, so I have entered, I've selected transaction. So transaction selected can be the next state, and again you can again cancel your pin any cancel transaction anytime. So which we're going to take transaction portal. Okay, so now we have defined two different states. Transaction selected, transaction aborted is already there. So transaction aborted can be defined all now itself. You can, that's a final state, right? So it is like a type final yeah. Okay, it still needs this. Okay, no worries. So now we are going to take transaction selected. Okay, which is a new state. And we're going to make it, we are going to have two different states again, which is going to be like two different actions, withdraw money. So which is going to take about, okay, now dispense cash, right? So it's going to withdraw, which is another state. And from what you can also again cancel the transaction anytime you want. Transaction abort. Transaction aborted. Yeah. So once we have the transaction aborted, then it's basically about withdraw. Wait, I did a mistake here. So it's transaction selected is going to take us to withdraw, and then withdraw we are going to. Why is this highlighted red? Okay. Anyways. Oh, wait. It's okay. It's just that I haven't added it as part of my on, which is the syntax to create a state. Okay. So now withdraw will be taking us to two different selections where you can enter the amount or again cancel it, right? So enter amount, which is going to be amount entered, or you can cancel it. Transaction aborted, right? Yeah, I will quickly just trying to make it easier for people to understand this, right? So now we have amount entered is the amount that we have. So now what once you have the amount entered, you basically have to dispense that amount, right? So amount entered will have is another is going to be a definition of this new state, which basically takes up to dispense amount or dispense cash, right? And that's an event that takes us to dispense cash state, or I can name it better anyways. Anyways, so it's going to be again cancel, and it's transaction aborted. Okay, so what are we now? Okay, so now we have, oh, okay, we don't have a dispense cash method, so we have to specify dispense cash as a final state, just like how we specify transaction aborted. Remember the diagram? Like we have a cross where it shows this transaction aborted, and then we have a money icon, which helps us to show that it is cash being dispensed. So it is going to be like type final and come on. Okay, so now we have a state machine build. I'm just trying to minimize this so that you can always see it. Maybe I can just drag it down to the left. Okay, so now we have a state machine where we have insert card, and then we have we enter the pin, and then Once we enter the PIN, we select the transaction, and then we can withdraw the money. We can select withdraw transaction, and then we can specify the amount that we want, and then we can dispense cash. Well, how does it work? So if you look at insert card, it basically takes us to two different flows. Cancel will take you to the final flow where transactions are aborted, and at the same time, oh wait, I think it can reset. Insert card, you enter the PIN, and once you enter the PIN, you can see that you can again enter the select transaction or cancel. So you can select the transaction, which will take you either you can specify withdraw or check balance. You check the value and you select withdraw, and all of a sudden you can see that you have to specify the amount that you want to enter amount, and basically it takes you to dispense cash. Will take you to the final stage where cash is being dispensed. So this is a very basic state machine. We are not creating a model-based test here, which is just a very basic state machines here. So are things clear? I just need to know if people are able to do this. I mean, people are able to understand this. All right. Cool. So now we have created a state machine. I just want to quickly show you an example where we have built a model-based test. I have it already here. Okay. So before I even go to this model-based test, around 31 minutes. Okay. Yeah. So before I move to an example of model-based test, I would like to show you a very basic example as well here. So let's just close this, and this is a very basic Google search, right? So so if you can relate the ATM, if you can relate an ATM part, yeah, I could see a lot of laughing emojis. Yes, it's a very basic Google search, just to make things clear. So if you can relate to an ATM, where I have explained about the create machine method, which helps us to create a machine, and then you have a ID, which is basically with the name of the machine, and then the initial state, and then this is a transact, this is the event, and then this is the next state. So you can also expect, I mean, we can use this meta tag, which basically is a metadata. You can use this to validate your state before even you perform the next action. So this is how a very basic model-based test would look like. So if I have to go to the one that I have done for this, so there is this website which I found recently, which I thought it's very simple for us to do the actions. And I took this as an example. I built a model-based test based on this. So if you look at there are two things. To build a model-based test, you have to create a model, and then you have to also use Playwright in it, right? So to create a model, you need your state machine, you need the states, you need the events, and then you need to specify the events as part of the model. So that's what we have done. I'll go through that. And then there are how are your test paths being generated? So based on the models, just a minute. Yeah, and then now we have so when we have the model ready, now and the paths to the different states and events, then we just need to wire it up with Playwright, and or even you can even use Cypress. I mean, it's not about the libraries. You can even use Playwright or Cypress. So once you iterate over the different path plans, and based on that, if you run the test, it will basically execute the test. So if I could show you now, I will quickly execute this test. So, so it says 17 tests. Okay, so I will show you all the things. The action is basically like you enter, you go to the page, select the pet, and then go to the list of animals that's available, and then you click on add cart, and then you go back. So if you look at the model now, I have specified my states, pretty much encapsulated the states into different classes, different files, so different files, so that you can basically, I don't really want to see a state machine just like this, which looks quite ugly. And if you look at, so let's go to the welcome page state. What does it contain? Okay, let's go to the state and welcome page state. So it basically contains the initial state, and then the event, and then the next state. The initial state enter store is added here, where you have enter store is basically to click the button, enter the store. Okay. And similarly, if you go to the model, if you go to homepage state, where you, if you look at this website, if I can launch this myself, there's a welcome page, and then this is the home page. Then we have fish page, and then we have dog page. So different pages based on the names, but yeah. If you go to the home page states now, you could see that you can click on fish, dog, cats, reptiles, etc. You can take it to the own page. Though you don't really have to segregate into separate classes like this, but it basically, just for the purpose of showing and demoing, I just made it kind of different, kind of segregated here. So if you have to build a model, all you have to do is, as mentioned, you specify the ID, the initial, and if you look at the initial state, which I've added here is welcome, and if you look at the welcome page state, that's the one here, and then this is the transaction. Sorry, this is the event, and that's taking to the next state, which is basically home page. And if you go to home page, that's the state that's here, and it will click onto the next action, which is click fish, click dog, click cat, click reptiles, and click birds. Then it'll again take to the next page, where fish page has been the next state, fish page. Then it performs select product and takes to a next state. And then it clicks on does add to cart, and then takes to the next state. And that's basically where we are. So all the meta that you see is just additional information. As I mentioned, you can basically this test or something is something that you can change all your own. You don't really need, it's a custom key. You can change it to check. So it shouldn't really be a problem. Yeah, so where do I define these transactions? I defined it in the corresponding page events, just on the events. So if you see here, there is click fish, click dog, click cat, reptiles, birds, etc. And if you go to fish page, it's select product and add to cart. So it's very basic example, pretty basic, so that it's something that we can follow. Well, if you see here, I have talked about states and events, but I haven't really talked about the model, right? So to create a model, you need a machine and the events. Okay. Excuse me. Yeah. So to create a model, you need a machine as well as the event. So once we use this method, create model, which basically helps us use the machine as an input and then creates a model with the events that we have specified, we have a model here. So there are different ways that you can iterate. So if you look at this, well, I haven't really shown the report, I guess. Just a moment. So it should show you the report. Well, this is the report. So as I told, it's very describable, right? So it's going on. It's the first step is like enter store. It goes through every single path that's been every single state that we have described. So it's enter and click fish, enter and click cat, enter and reptiles, enter and birds, and then followed by that it goes to the next part where we select the product, and then we go to add to cart page, and then we can even go further, like proceeding with the payment, etc. So this is quite exhaustive. And just in case if you don't need exhaustive tests like this, you can even make it shorter. So there is something called get shortest path, which basically helps us to find out the very basic ones. So if I run my test now, what basically happens is that it would just go to iterate towards the most unique path, and then see, it's now from 17, it is now to 7 tests. So let me quickly show the report here. And so now it is here is enter store once, enter store fish, enter store dog. Now it is about fish and select the product and then add to cart. So you previously had this whole path multiple times for each of these products. Now it is just one path. So we have brought out the test from 17 to 7, just because of the path that we want to iterate. Excuse me. So yes, I think I would like to do more, but we have just 5 minutes left. So I would be open for questions now. I can stop sharing. I really want to do something with the further ones where where is that? Where I would proceed from shopping cart to checkout, but I'm so sorry for that. Due to time constraints, we have to stop now. So I will stop sharing and I'll be open for questions. I hope my session was informative and people are able to follow.
Yeah, thank you, Gopi, for that enlightening session. We have got a few questions from our audience. Let's take them up. So we have a question from Jay. How can state machine help in scaling test automation frameworks, especially in high velocity environment like yours?
So if I have to answer this question, it's more like scaling test automation framework. So you have to start building it on your own, not on your own, like from as early as possible. So remember when I talked about it's not very easy to abruptly introduce state machines or model-based testing into the project because it's not easy because there are a lot of paths, there's a lot of states, and your application can be smaller and bigger. And especially if it is like a bigger application, then you'll have a lot of states and events and transactions which you have to take care. It will be quite a complex setup to work on. So I don't know if I've answered the question, but introducing into the later part is not something that we should be doing. That's quite complex. And if you say scaling test automation frameworks, I think I answered the questions if I'm not wrong.
Sure. Let's take another question. This question is by Cassie. What are some common pitfalls that should teams avoid when implementing state machines in their test automation processes?
Again, the same answer because we need to introduce this as early as possible because if we are building it earlier, right, along with the development, it's very easy for us to proceed further because all we have to do is update that state machine with one more state and events and then go and so on, right? So common pitfalls, if I could say the very basic one is about introducing it earlier.
Okay. So let me pick another question. This question is by Mukesh. He says, what are the key benefits of using state machines in combination with Playwright for test automation?
Well, it depends. I mean, it's a very good question. It's a very good question. I was expecting this question. So it depends, right? So let's say that you're working on a kiosk, right? You have building application for kiosk. So your application would be like in screens. You can just it's like turning the switch on and off, right? It goes forward and backwards. So that it suits well there. Whereas in some other complex web apps, it might not be the perfect choice. So the key benefits to using state machine in combination Playwright, it certainly completely depends upon the app that you are using.
Okay, great. Let me take another question, and this one is by Vijay. He's asking, can you provide examples of complex testing scenarios where state machines increases significantly improve the reliability and maintainability of your Playwright scripts?
Can you provide examples of complex states testing from US state machines? Well, maintainability in terms, if I had to talk about maintainability, it's quite maintainable in terms if you understand how state machine behaves. So if you understand the problem, the biggest common common pitfall or common caveat when it comes to using state machines is to understand state machines. So if you're not able to understand state machines, we will not be able to properly use it, and it will take a lot of time. And then maintain the script would be a nightmare. In fact, there are different. XState is not meant for just automation. It's more like Redux, right? You can store your state like a front-end framework where you can store your state and then you can basically perform actions on the UI. So this is just using XState with Playwright for a use case which I have in my current team. Yeah.
Okay, I think we are running out of time, but I'll still pick up one last question. Uh, this question is from Arbor. He says, "What is the future of Playwright with AI being implemented in all products?"
I don't think it's related to state machines anyways, but we can. I mean, it's not related to the session because Playwright with AI. I mean, we're not using AI here. It's just state machine libraries. So
Mhm.
it's more about model-based testing and not using AI in our testing.
Okay, well, that does it. Thank you, Gopi, for this insightful session. For people who have more questions, feel free to connect with Gopi over LinkedIn, and he would be happy to take any questions over there. And rest of all the unanswered questions, they will be answered over in our Lambda test community. The link is pinned in the chat box. And also, once again, I want to say that this session will be available in our Lambda test YouTube channel after the session ends. Once again, thank you, Gopi, for sharing
Thank
your
you, Swapnil.
expertise
Thank
with
you,
us.
everyone.
I'm sure everyone has gained some valuable insight that they can put to use. Wish you a very productive day. Thank you.
Thank you. See you all.